Hello and welcome to Mr. Tompkins EdTech. This series of videos provides work solutions for the GCSE Maths topic test produced by AQA. This video is Inequalities. Whilst these topic tests make excellent exam preparation and revision material, regardless of which exam board you're sitting, they are particularly useful for students studying for AQA as they are prepared by the same team who will be writing your papers in the summer. They will work best if you try and answer the questions yourself before watching the video. The topic test papers can be downloaded from this address, which I've also linked in the description below. They'll require a teacher account to access, so either ask your maths teacher to download and share them with you, or alternatively you can try pausing the video and attempting the question first before pressing play again to listen to my solutions. Check this playlist for all the other topics I've covered. I'm busy recording all of these topic tests, so if the particular topic you're looking for isn't there yet, why not drop me a comment below with your request and subscribe to my channel to receive notification of future uploads. If there is anything you don't understand, please ask in the comments. Make sure you mention the question number and try to be as specific as possible. I try to answer all questions promptly, especially around exam times. If you found the video useful, please do hit the like button as this really helps me out. You might also like to check out my exam paper walkthroughs covering all the recent papers and practice papers from AQA. Just click on the card appearing at the top of the screen now. Okay, let's get started. Before we get started, I'm just going to show the blank question paper. So if you don't have a copy, you can now pause it and have a go at the questions first. And then once you're finished, you can start again and look at the answers. Okay. Welcome along to another AQA topic test. This one is Inequalities. It's a foundation level test, although it's suitable for higher tier as well. Okay, question 1. Here is an inequality. X is greater than 2. Circle the letter of the diagram that shows the inequality on a number line. Okay, so just a few things to note here. You've got a greater than symbol there. That means x needs to be bigger than 2. It cannot equal 2. So if you're going to show this on a number line, you need to use an open circle and not a filled circle. So it's not going to be this one or this one because they are filled circles. It's going to have to be one of the other two. Okay, and x is greater than 2, not less than 2. So the arrow needs to be pointing up the scale rather than down the scale. So the correct solution then is C. Okay. So open circle means strictly greater than, not greater than or equal to. And we're going off to the right, which means x has got to be bigger than 2. Okay, so here's an inequality. Minus 3 is less than x, which is less than or equal to 2. Circle the set of integers that obey this inequality. Okay, now if I was going to show this as the same way as that question above, I'd have a number line running from minus 3 up to 2. I'd have an open circle at 3 because 3 is not included in the range, and I'd have a filled circle at 2 because 2 is, and then my range is all the numbers in between. Okay, so if you think about the whole number values that lie between those two limits, then I can't have 3 because I've got an open circle there. It's strictly greater than minus 3. I could have negative 2, I could have negative 1, I could have 0, I could have 1, and I can have 2 because I've got a closed circle at the other end. Okay, so the numbers that are acceptable are minus 2, minus 1, 0, 1, and 2, which is, so it is B, minus 2, minus 1, 0, 1, and 2. It's that one there, isn't it? Okay. Question 3. Here is another inequality shown on a number line. I've got minus 2, minus 1, 0, 1, 2, 3, and 4 drawn on this scale. Note that I've got an open circle at 2, which means that minus 2 is not one of my solutions. Okay, but I can have minus 1, 0, 1, 2, 3, and 4, and any number almost down as far as minus 2. So circle the algebraic inequality that defines this inequality shown on the number line. at the bottom end, I'm going to have a strictly greater than symbol, aren't I? For x is greater than minus 2. So it's not that one. It's not greater than or equal to. And it's not that one. It's not greater than or equal to. So it's got to be either the first or the third one. Looking at the other end of the line, I've got a solid or a filled circle there, which means that 4 can be part of my solution. So that means it's not that one. It's got to be that one there. Okay. So at the bottom end, I've got a open circle, which means my endpoint is not included. And at the other end, I've got a filled circle, which means my other value is included. Okay. Question 4. Work out the smallest integer value that satisfies 4x plus 3 is greater than 20. Okay, so we've got a linear inequality here. Now, if it was an equation, 4x plus 3 is equal to 20, would you know what to do? Well, what you need to do is try to isolate x, don't you? So you'd subtract 3 from both sides first to get rid of that 3 next to the 4x. So that would cancel with that, and it would just leave you with the 4x on the left. 20 subtract 3 is 17, and then I would divide by 4, wouldn't I? So divide by 4, divide by 4, and that would leave me with x is equal to 17 over 4. Now I could write that as a mixed number. 4 goes into 17 4 times remainder 1, so I could say that's the same thing as 4 1/4. I could even write it as a decimal if I wanted to, 4.25, if I put it into a calculator. But actually, it's perfectly acceptable just to leave it like that as a top-heavy fraction, so why bother? I'm just going to leave it like that. Okay, so that's what I'd do if this was an equation, but it's not an equation, it's an inequality. But actually, the method is just the same. So rather than having an equal sign between these two things, I'm going to have a greater than sign, and there it's going to be a greater than sign, and there is going to be a greater than sign. So actually, the method is totally the same as solving for, an equation. So, done. Question 5, solve 2x minus 6 is less than 3 minus 4x. Again, I'm going to solve this exactly the same way as I would have done an equation, but rather than having an equal sign between my things, I'm going to have that less than symbol instead, aren't I? Okay. Right, so what am I going to have to do first to simplify this? I think if I can add 4x to both sides, that would be a good start. Add 4x, because then that will cancel with that and just leave me with numbers on the right hand side. So what will I get? 2x plus 4x is 6x. So now I've got 6x minus 6 is less than 3. Okay, next step, let's add 6 to both sides. Okay, and I'm going to get 6x. These two are going to cancel each other out, so just going to leave me with 6x. 6x is less than 3 plus 6 is 9. And then finally divide both sides by 6. Okay, I'm going to get x is less than 9 over 6. Now I'm going to cancel down this a little bit because both top and bottom can divide by 3. So I'm going to just cancel that down to 3 over 2, 1.5. So x is less than 3 over 2, or x is less than 1.5. Okay. Okay, let's have a look at 6a. Solve the inequality minus 7 is less than or equal to 3x minus 4 is less than 9. Okay, now I've got 3 parts of an inequality now. I've got this bit on the left, which is smaller than this bit in the middle, which is smaller than this bit on the right. Okay. Now, again, you can do these very similarly to how you would solve an equation, but obviously you've got 3 parts now, not 2. Okay, but as long as we do the same to all 3 parts at the same time, our inequality should hold. So if you look in the middle, I've got 3x minus 4. Now I want that just to be x by itself. So I'm going to do very similar things as I would do with solving an equation to kind of simplify that middle bit down. So first off, a 3x minus 4 in the middle, if I add 4, it will get rid of that 4, won't it? But if I add 4 to the middle part, I'm going to have to add 4 to the right part, and I'm going to have to add 4 to the left part. So what is that going to give me? So on the left, I've got minus 7 plus 4, which is negative 3 then, isn't it? And then that is less than or equal to 3x minus 4 plus 4. These two bits are going to cancel each other out and just going to leave me with a 3x in the middle. And on the right hand side, I've got 9 plus 4. So that is going to be 9 plus 4 is 13. Okay, now notice that the inequality symbols are the same. They don't change, they just kind of carry those down. Whatever they were to start with in the top one, they're still that same thing. Okay, so we're almost there now, but I've got 3x in the middle. So if I divide it by 3, I'm going to get those cancel out and just leave me with x. So, but if I divide the middle bit by 3, I've got to divide the right hand by 3 and the left hand by 3. Okay, so minus 3 divided by 3, well, that's just minus 1, and that's going to be less than 3x divided by 3. The 3 is going to cancel, leaving me with the x. And finally, 13 divided by 3. Well, I could say 3 goes into 13 4 times, remainder 1, and write that as 4 and a third. But again, it's also just acceptable to leave it as a top-heavy fraction like that, so I'm not going to bother to do anything. Oops, not a 4 though, it's a 3, isn't it? That would have lost me a mark. Okay, good spot. So 13 over 3. Okay, so that's my final answer. Minus 1 is less than or equal to x, which is less than 13 over 3. So actually, there isn't a lot extra to learn for inequalities. If you already know how to solve linear equations, then inequalities is just like a bit of a bonus thing for you. 6b, here is an inequality drawn on a number line. I've got a line going from negative 2 up to positive 3. But the negative 2 is an open circle, which means that negative 2 itself can't be part of the range. At the other end, I've got a filled circle, so that means 3 is fine. And all the numbers in between are fine as well. So minus 1, 0, 1, and 2, they are all integer values that obey the inequality. Okay, so the numbers that obey this inequality are the numbers minus 1, 0, 1, 2, and 3. Now we need to write down all the integers that obey this inequality and your answer to part A. Okay, so coming back to my answer from part A, what was my answer? It was x lies between minus 1 and 13 over 3. So I had x lying between minus 1 and 13 over 3. What were the symbols? Less than or equal to. Okay. Now, I am going to rewrite 13 over 3 this time as a mixed number. 3 goes into 13 4 times, remainder 1. So I can rewrite 13 over 3 as 4 and 1/3. And the reason I want to do that is because I actually want to see what number it is. So when I draw my number line, it matches up. So it starts at minus 1 and goes up to what am I doing? Minus 1, 0, 1, 2, 3, 4, 5. Now my number has to be greater than or equal to 1, so that's a filled circle at that end, and less than 4 1/3, which is going to be somewhere like that, isn't it? Okay, but not included anyway. So all the numbers in between there. So what are the integer values that do work in that range then? Minus 1 is fine because it's a filled circle, can be equal to minus 1. 0 is fine, 1 is fine, 2 is fine, 3 is fine, 4 is fine, and 5 is too big. Okay, so what is the same on both of those then? Write down the integers that obey the inequality and the answer in part A. So which ones are on both? Okay, well, minus 1 is on both, 0 is on both, 1 is on both, 2 is on both, and 3 is on both. 4 is not on both. Okay, 4 is just on my answer for part A, but not on my answer for part B. So what are the integer values that obey both inequalities? Well, I'm just going to write those answers down then. So minus 1, 0, 1, 2 and 3. Question 7. All measurements are in centimetres. This rectangle has sides of 3x plus 4 and 2x minus 3. And you're given that the perimeter is less than or equal to 55 centimetres squared. Work out the maximum area of the rectangle. Okay, so I've been given the two sides of this rectangle algebraically. One of the sides is 3x plus 4. One of the sides is 2x minus 3. Now obviously the opposite sides in the rectangle are equal to each other, so this one is also going to be 3x plus 4, and this one is also going to be 2x minus 3. Okay, so if I add those four sides together, I'm told that it's less than or equal to 55. Well, let's add it together, but let's add together all the x values. So I've got 3x, 2x, 3x, and 2x, which adds up to 10x. And I've got 4 and minus 3 and 4 and minus 3. So 4 plus 4 is 8. Minus 3 minus 3 is 2. So I'm going to get 10x plus 2. And I know that perimeter is less than or equal to 55. Okay, so I've formed an inequality in x. Now we can go on and solve this just like we did with the other ones earlier on, trying to get x by itself. So I've got plus 2 there, so I'm going to subtract 2 from both sides to get rid of that part. And it's going to leave me with 10x is less than or equal to 55. Subtract 2 is 53. Dividing both sides by 10. That's going to cancel with that, leaving me with just x. So x is less than or equal to 53 over the 10. I'm just going to attempt to write that as a decimal, actually, 5.3. Okay. Now, what is the maximum area of the rectangle? Okay, well, what's the maximum area of the rectangle? Well, what are the sides? An area is length times width, isn't it? So the area of a rectangle is length times width. So the maximum area that can be is when x is at its biggest. So we're going to take x to be this value here, the largest value it can be. Okay, now if x is 5.3, then 2x minus 3 is what? It's going to be 2 lots of 5.3 minus 3. So let's just sub 5.3 into this. So, oops. So 2 lots of 5.3 minus 3, what's that then? 2 lots of 5.3 is 10.6. 10.6 subtract 3 is 7.6. So the length then, or the width, is 7.6. And the other one, what's the other one then? So let's sub in 5.3 into here. 5.3, 3 lots of 5.3 plus 4. So 3 5.3s is 15.9, plus 4 is 19.9, isn't it? Okay, 19.9. So my area, the maximum possible area it can be, is 7.6 times 19.9. Now I'm going to reach for a calculator here and type it in. So 7.6 times 19.9, that comes to, now according to my calculator, that is 151.24. So then that is my maximum area then, 151.24. Question 8. All measurements are in centimetres. Here is a triangle, x plus 3, 2x plus 4, and 10. Work out the values of a and b such that a is less than x, which is less than b. Now, if you've got a triangle, then, well, I know this side here is got to be 10. So if you think about it, then this side and this side, the very smallest they can be is 10, because otherwise they're not going to reach across there and it's not going to form a triangle. So the two sides, x plus 3 and 2x plus 4, have got to be at least 10 in together. Otherwise they're not going to reach across and form a triangle. So I can say that those two sides, x plus 3 and the other side, 2x plus 4, between them have got to be greater than 10. Okay? So then collecting like terms, I've got x and 2x, which gives me 3x. And I've got plus 3 and plus 4, which gives me plus 7 is greater than 10. And then solving now for x, subtract 7 from both sides, they'll cancel. That will leave me with 3x is greater than 3. And then dividing by 3, they'll cancel. And it will leave me with x is greater than 1. Okay, so that 1 then, that's got to be that a there then, isn't it? So my x is going to have to be greater than the 1. Now I need to know what it's going to be less than. What I can do is I can have a similar argument going on for two of the other sides. So just like my x plus 3 and my 2x plus 4 needed to be long enough to reach across that gap of 10, we could take two other sides. I could say, well, my if I say this side is 2x plus 4, then this side, the x plus 3 and the 10, have got to be greater than 2x plus 4 as well, otherwise it's not going to form a triangle. Okay, so I can say that x plus 3 plus the 10 has also got to be greater than the other side, which was 2x plus 4. Okay, that gives me a different inequality that I can go on to solve. So collecting like terms on the left, I'm just going to kind of write it up here because I'm running out of space. So let's just move that across. So x plus 13 is going to be greater than 2x plus 4. Okay, let's subtract x from both sides. That cancels with that, leaving me with 13 is greater than x plus 4, and then subtracting 4 from both sides. That's going to cancel with that, leaving me with 9 is greater than x. Okay, so then x is less than 9, so that's got to be my b value up there then, isn't it? So x has got to be bigger than 1 and it's got to be less than 9. So 1, 9. Well, that's that. I hope you found the video useful. If you did, please hit the like button and consider subscribing to my channel. Also, check out the playlist on the right for more topic tests or the one down below for past papers. See you again next time.